Today we're gonna discuss a problem which is ID generation. How do you generate IDs on a large scale? I mean, if it was a single machine, it is probably no problem. A sequence and this sequence increments and so on. Okay, somebody might suggest UUID or GUID or other 128-bit values that is generated randomly using a sophisticated algorithm, maybe some hashing on a randomly generated number. Okay, but what if this wasn't enough? What if it wasn't sufficient for us? We need these IDs to be numeric, to be sortable by time. So if an event takes an ID, this ID happened at time A come before time B, so event B gets an ID too. So if we sort them in a sequence, event A would come before event B as if they was originally generated or happened. So that takes UUID and GUID out of the scope. Okay, we can make mutual looks, generate an ID or a sequence, look it across the globe, across many multi-data centers. So maybe blacklist it to several machines, maybe some kind of communication between data centers or machines that, okay, I have taken this ID, did anyone take it before? Yeah, but it's kind of slow. We wanted to support large traffic, let's say 30 or 40 billion IDs per second. I know, it's a huge number. So, how do you solve this problem? Luckily, Twitter have solved it in 2010, and Instagram started using it in 2015, and it's very interesting solution that is really easy to implement, and I believe it's open source. I'll be posting the link in the description below. And let's go. So, how do we do it? Billions of IDs per second. Across the globe, unique, sortable by time. Yeah, it's a tough problem. In just 64-bit. So the solution is quite simple. You can Google it. It's called Twitter Snowflake. Originally developed by Twitter, then used by other companies such as Instagram. So here we go. Basically, they take a 64-bit integer, standard 64-bit integer, and we make bitwise operation on it. We're not supposed to play with the most significant bit as it's a signed bit. So, out of the game, we left with 60C. Let's assign the first 41 bits in this integer completely to a timestamp. A timestamp, Unix timestamp, that is millisecond based. Yeah, it's 41 bit. This would make it sortable by time. But time is not the only requirement here. We've got to make it unique. How do we do that? Let's take 5 bits to represent, let's say this is a timestamp. The next 5 bit is the data center ID. 5 bits more for the machine ID, and 12 bit for the sequence generated on this machine. So, what is the capacity of the system? Let's find out. Bring the calculator here and check. We've got 12, so 2 to power 12 to start with. That's for about 4,000 IDs per second. Sorry, per millisecond, per machine, per data center. Let's calculate it all. And we've got 32 machines in each data center, and we've got 32 data centers. The number is getting bigger, and that's per millisecond law. So let's crack things up and make it per second. So we've got 41 billion IDs per second. That fits in 41 bits. That's sortable by time. That is globally unique across the world. So I really hope you like it. I know it's a small topic, small episode, but it's a very interesting problem with a very, very interesting and simple solution to begin with. Thank you very much. If you like the channel, please subscribe, hit the like button, share it with your friends, and stay tuned for next episodes. Please make suggestions if you like anything to discuss. I am open to it. Maybe if you like an implementation, we can do something here in whatever language you like. Please have fun and see you next time. Bye bye.